start kind of backwards a little bit here. We're going to kind of work our way into this on some things with combining like terms. I'm not going to do all of them at the top, but we're going to do a select few just to kind of get us thinking about this a little bit again. So let's see here. Well, number one, that's a pretty easy place to start. Do we have any terms that are alike in number one that I could put together? Yeah, which ones?
8x squared and 7x squared.
Yeah, 8x squared and 7x squared. They have the same exponent. So when I do that, I add the numbers in front together, but I don't mess with the exponents ever. We only do that when we're multiplying or dividing. And then there's no other 8x to the third, so we can just leave that one there. You're like, okay, that's not too bad. I can handle that. But what about when we do have to start multiplying? What about in a situation like number 2 where I have to distribute? That first one's the one, if we're going to get stuck, that we're probably going to get stuck on. If I take 7 and then I do x times x, what's x times x equal? X squared. Nicely done. And then 7 times negative 3 would give me negative 21x. And again, I can't go any further because x squared and x, even though they're the same variable, have different exponents. So I'm done with that one. Oh, let's find another one that's going to be kind of like that. Let's jump over to 4. Again, we only distribute to what's right after with our parentheses. So I'm not going to do anything to 2x squared yet. But then we get into a situation sort of like we did over here. 3x times x, excuse me, is 3x squared. And again, 3x times 4, no other x's this time, just multiplying the values in front, my coefficients. And just like the other ones, we're just going to find what's alike at that point and combine them and go about my business, go on my way. Now, is that what we're going to be doing a lot of here? No, it was just to kind of reintroduce, oh yeah, if I multiply these together, my exponent can change. What we're actually going to be doing is working our way down into some of the rules that go along with this. So this might be one of those note sheets it's good to have around somewhere. So here, if I'm multiplying with exponents, like bases just mean it's the same variable that I'm working with. I want to look at it with you expanded out and then figure out what the rule is. Now, I'm not going to do this on every single problem. This would be crazy. X squared just means I'm multiplying two x's together. Okay? X to the third just means I'm multiplying 3 x's together. Now, when I multiply them, I don't see an exponent on any of them. What exponent's on a variable if I don't see one? 1. So these all have 1s on them. So I've got 1, 2, 3, 4. Okay, I got 5. So x to the 5th. That'd be my answer. And we might start to see if we do this a couple of times. She's like, ooh, 6 x's. That's a lot of drawing. And again, we're just doing this right now to kind of let you visualize what the rule is. We don't need to do this every time. That'll get kind of tiring. And you're not going to have that much room most of the time either. But it just lets me see that if I write out the 6 x's that I'm multiplying, and I write out the 3, and then I just count up the exponents, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can start to see what the rule in general would be. I'm like, hey, 2 plus 3 is 5. 6 plus 3 is 9. We might be onto something here. Now, the only one I think could get a little more interesting is going to be letter C here. Because now there's a number in front, and here's what I've got to be aware of. This one, and I'm actually going to write this one out too, that 5 only goes to the x. Okay, it doesn't go to the 3. So it's just a 3 with 5 x's. This other one, the 4, only goes to my x. Okay, it doesn't go to the 4 here. So it's my 4 and 4x's. And again, they all have exponents of 1 because I didn't see any others. Numbers, I still just multiply. 3 times 4 is 12. X's, I just add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically, yeah, it's not bad. And then, now, here's the one interesting one, though. What's anything to the 0 power equal? 1. And that's anything. That's even like if you have 3 to the 0, that equals 1. If you have 4x squared y cubed z to the 4th to the 0, it's still 1. Okay, so anything to the 0 power is 1. It wipes out the variables and all that other stuff. So our rule here is going to be when you multiply, you add the exponents, but I'm still going to multiply the coefficients, or the numbers that are in front. And I've got to keep that straight, because if I just add these and call it 7x to the 9th, that wouldn't be right. So when we're multiplying, we add exponents. Now again, we're not going to do all of these, but we are going to attempt to use the rules just to see how quick this can go. Here, it's just x to the 3 plus 5. You're like, it's just that quick? It's just that quick. Add them up. 11 plus 2, 13. On to the next problem. The thing I've got to be careful of is when those numbers start to sit in front. So like here, I need to multiply the 3 and the 5 together, but then I can just add the exponents again. If I only have one number to play with, okay, I can use 8, add the exponents. So really, it's just one basic rule. Now, what happens when I start throwing other variables in? What if there's not just one, just x? There's x and y. Same idea. I'm still going to multiply the coefficients. So 8 times 2 is 16. And I'm going to find the ones with like bases. So like x's go with x's. Add their exponents. Y's go with y's. Add their exponents. Straightforward as that. Multiply coefficients. Add exponents with like bases. Add exponents with like bases. Cool. And just remind yourself, because 20 might look like the easiest problem, but it actually doesn't end up being a lot of the time. What's that exponent again on an x if I don't see one there? 1. So I have to remember that and make this x to the 6th, because a lot of times people just write x to the 5th, or they'll write like 2x to the 5th, and I'm like, aha. Okay. So when we're multiplying, we're going to add those exponents together. Seems strange, like when I multiply, I add. That's kind of weird, but that's the way it goes. So I flip over, I'm like, dang, there's a lot more of these. Now again, we're not going to do all of them, but I do want you to see how some different things can work here. Okay, again, multiply the coefficients. 7 times negative 4 is negative 28. Add my exponents to the like base. 6 and 2 is 8. And I've only got one y term, so I don't really have anything to add it to. And I get that. And the rules even apply if your base is a number. So for instance, if I get down to like number 27, still just add them up. 2 plus 4 makes it 5 to the 6th. I'm good. 3 plus 4 is 4 to the 7th. I'm good. So that's all I'm doing on any of these. I'm trying to see what else could cause problems here. Could 33 cause problems? Maybe. If I multiply my coefficients in 33, what do I get? Positive 10. And then 2 plus 4 is 6. So multiply the numbers in front, add your exponents. The only other weird thing that can get thrown in here, and it'll be the last thing we're going to touch on here, is going to be what's called power to power. What happens if instead of being inside the parentheses, my exponent's outside of it? Basically what that means is everything that you have on the inside gets multiplied together. Now it kind of looks like the problems we were doing up above. I still am going to multiply my coefficients. And my exponents, I'll write them in here, I'm still going to add them up. But now instead of just being on the x, it's with my number as well. Now this gets a little more interesting as we start doing this. And just like we did with the multiplication, I'm going to write all this out the first couple of times we do it. So basically I'm letting that 3 tell me how many times I'm going to write this set of parentheses down. Because then it looks like what I'm doing up above. I multiply the coefficients. So I do 2 times 2 is 4, times 2 is 8. Add the exponents on my x's, 2, 4, 6. And add the exponents on my y's, 3, 6, 9. And I'm good. Some funky stuff going on here. Ooh, C to see if we're paying attention. What's anything to the 0 power again? 1. Even if it's some big, huge, crazy thing with a bunch of different variables, you see that 0 power? 1. Automatically. Well, what if they give me something and then they put the squared out here? What do I do? Here's my suggestion. I'd simplify what's inside first. So I'd multiply the 3 and the 2, get 6. I'd add my exponents on my x's, x to the 6th. There's only one y to the 4th here. But then I'm going to take a look for a minute before I write this out, because I should see a pattern here. I look at this and I'm like, well, I might not see it with this one because I'm still adding. But here, 2 times 3 is 6. 3 times 3 is 9. I wonder if once I do this, if I were to go 6 times 2 is 12, 4 times 2 is 8, but then 6 squared, when I would do that to this one, because basically I'm just multiplying this through, 6 squared, what's that equal? 36, because it's just 6 times 6. So let's see if that works if we actually would have written this out. If I'd have written this out twice, and used my multiply rules, 6 times 6 is 36. 6 plus 6 is 12. 4 plus 4 is 8. Okay, so this works. Power of a power, when that happens, we're going to multiply the exponents. And if I don't see an exponent, again, we just assume that it's 1. So what I'm going to have you do to kind of get some practice, because that's, again, how any of these things are going to kind of drill into your brain. The multiplying and power practice over here. I want to do a few of these with you, just a few. I want to look at 6. What am I talking about? 10. Maybe 13 here. And then we'll take a look at a few on the back too. So if we start with 6, and just a reminder, Let me make sure I'm doing this right. Okay. Homework check for assignment number 2. So I start to look at this and I go, okay, I see exponents, so I know what I'm multiplying, I got to add my exponents. So I'm going to do the variable part first. So I got 5, I got 3 more here, which would give me 8. With my y's, I got 0 plus 3 is 3. But again, with the coefficients, with the numbers out front, I'm still multiplying those. So negative times negative is positive. And I get my answer and I go to the next one. Now the next one, that's where this starts to get a little weird. What do we say anything to the 0 power equals again? 1, which basically is going to wipe those out. Because even if I multiplied my exponent, 0 times 5 would be 0. So this is just 3 to the 5th power, which is 3 times 3 times 3 times 3, one more, times 3. And if you left it as 3 to the 5th, I wouldn't mind, but I'll go ahead, we'll multiply it out and get your answer. But then I wanted to make sure we did the weird. Did I mention weird? Weird one. 13. That's a whole load up to the zeros. But here's what I'm looking at. That one on the very outside tells me that all this stuff is to the 0 power. So what's that mean? That whole big thing equals 1. Weird, but true. So when I'm doing any of these, ooh, I got some nasty ones in the back. Let's do a couple of these. There's some craziness going on the back. All right, we're going to look at 18 and 22 together, and then I will let you take off on your own here some. You're like, holy cow, Hardy. All right, exactly. This 3, okay, now I can do this a couple of ways. I can either take that 3 and multiply it with the exponents, bless you, to all of my terms in here. Or I could try to simplify what's inside first. I think for most of you doing the little distributing thing would be better. And again, I'm multiplying them. It's power to power. So m to the 15th, 5 times 3 is 15, times 3 is 12. Even this negative 2, remember, has an exponent of 1. So we'll deal with that this way for right now, because it's still going to have a power of 3. 3 times 3 is 9. 2 times 3 is 6. I think we're going to squeeze it all in there. So you're like, okay, if I've gotten all this distance, now what am I supposed to do? Now I can go back and find my ones that are alike. Like, there's an m, and an m, and an m, and I'll just add their exponents up. 4 and 15 is 19, and 9 would be 28. Then I go to the p's. And again, sometimes just marking them like I do here can help out quite a bit. So 3, 15 is 18, and 6 is 24. And then I got some q's working here. 12 and 6 is 18. And then I come back to the numbers. I'm like, what do I do here? Well, negative 2 to the 3rd. I could punch that into my calculator if I wanted to. And I'd find out that's going to equal negative 8. So negative 8 times negative 2. And I survived. So I got to do power to power. I got to do my multiply rules. I got to multiply coefficients. That basically covered everything except the 0 power. So whenever we're doing these, we're always going to work from the inside out. So even on 22, put my 1 there on my Q, I'm going to do this first. Okay, I'm not messing with this yet. So I've got negative Q to the second. 3 times 2 is 6. 5 times 2 is 10. And I'm not going to touch the rest yet, because I'm going to do one step at a time so I don't mess this up. And we'll kind of use this as an opportunity to experiment. Let's say I decide I'm going to simplify what's in here before I do the 2, which isn't a bad idea. So I'm going to change up colors here. I got 2 and I got a negative. So I got negative 2. I've got, I guess it doesn't matter what order I do these in. Q, 2 plus 4 is 6. P's, 10 plus 5 is 15. And I've only got one M term, so M to the 6th. And once I've done that, my last step, and yes, it is the last one, this will not go on forever, is to take that 2 and multiply your exponents. So here I've got negative 2 squared, which is 4. 6 times 2 is Q to the 12th. 15 times 2 is P to the 30th. And 6 times 2 is 12. Okay, no, thank you. And I'm set. The biggest thing with these is going to be, are you going to take your time enough to get there? Because I know the smaller ones you're not going to have any issue with. It's going to see when you get to the big ones, are you willing to take your time? So we got a few multiple choices here on the back. But otherwise, work on these other ones. We specifically got you some time here. We got about 20 minutes to work with, so we can have you good and ready to go with these, and hopefully get off to a good start with this